USB kind of stuff, a battery, USB sound card. And on the front, it has like a rotary encoder and an LCD and a power switch. So I want to refactor the code I wrote for it. It uses Fluidsynth, and I'm going to refactor the code that controls the UI to use the actor model. Oh, I just broke it. Goodness. It's not very good. Look at that. Push this thing in. I have to unscrew it and pull that out. Anyway. I had glued it together with JB Weld, but obviously it's not the right stuff for gluing that thing together. Let's just make sure that we are actually live on Twitch. Twitch. Twitch.tv. The legendary Josh Wolf. 1 minute 33 seconds. According to Restream, I might be live on... No, it says I'm live. It says I'm live on YouTube and on Twitch. Yes, it's working. Love it. Okay, let's go to the studio. Just give me the right one. Ta-da! It does. Cool. Update the system audio. To broadcast system audio, please update to the latest. No, I'm not going to broadcast system audio. Not for now. Let's have a look at my Boom 3D. I'm listening to some Silk music in my headphones. It seems to have stopped it playing. Yeah, turn up the YouTube Music desktop app. Well, go away. Oh. Still having problems with this kernel going nuts. It's only 66 degrees, the CPU. It's running it at 1.4 gigahertz. So for some reason, it has decided to, let's get rid of that, on. Is there a way I can turn on the turbo boost? CPU load 78%, so only 66 degrees, but the fans are going really fast. CPU scaled down, and then some kernel task has taken up all of the CPU. Anyway, whatever. Keep playing the music. Turn it down a bit in my headphones. Okay, so I'm going to refactor the code to use NACT. And at the same time, I'm downloading this Windows evaluation. So NACT is Node.js plus actors, and it's kind of pitched, marketed as NACT is Redux, but for the server. So if you're familiar with Redux, they reckon it's like that. But I've been thinking about NACT recently, and it kind of looks more like Smalltalk to me. Smalltalk is objects passing messages. It's like the ultimate in object-oriented programming. And I think that's the right approach to use for this menu on the synthesizer, because there are submenus, and I want to add another submenu, and I've added other submenus before, but every time I do that, the complexity of my menu class starts exploding. You know, like when you press that rotary encoder, this menu class has to know which menu is currently displaying, and then it has to, you know, you can see here it has knowledge of what happens inside. Well, no, it's just handling it to the on press. But with the actor model, what I can do is I create each of the submenus as its own object, and all this thing does, this will be the menu controller object, and it'll get an on press event from, you know, a callback handler at the very top level. Will just when it gets the on press from the controller, you know, from the physical controller, it'll pass it to the menu controller, and then what the menu controller will do is it'll simply send a message to the currently active menu, whatever's showing at that point in time. So it'll be a stateful object, and the only thing that it will have is like which menu is active. And so one of its messages that it will handle is the button got pressed. Another message that it'll handle is set this menu active. So any of the other menu objects, when they're active, they can activate another menu. They can just send that message to the controller, activate this menu. That's the first thing I'm going to implement here. So this is being done as a class, so I'm going to do it as a nact. Let's just dive in and start coding JavaScript. Okay, getting started. I might use PNPM, I think. Yeah, I'm using PNPM. So just put a P. Wah. Too many spaces in there. Bam. Oh, it's going to freak out because it's going to try to install the Raspberry Pi stuff. This is an issue because I'm using hardware on the Raspberry Pi. When I code on my Mac, it doesn't want to install the Raspberry Pi I/O library because it says the architecture is incompatible. Password? Why is it asking me for a password? Which password? I guess my user password. I'll just type it in. That's weird. Okay, did it work? Let's have a look. Nact. Yep, it's in there. Good. Okay, so, well, let's just copy this, put it into the main. So main has become pretty streamlined. And then, so just drop this in. Should be able to refactor to import. Yep, good. And then I guess I'm going to want to spawn a stateful one. So spawn stateful. Spawn stateful. Well, I guess spawn is for stateful, yeah. And then we got to start the nact system. Boom. You can create your first actor spawn stateless, and then you can dispatch a message to it. Okay, so let's go straight to stateful actors. Spawn, yeah. Okay, so we'll create a new class called the menu controller. Create a new one, and we'll call it menu actor or menu controller. Menu controller actor. .ts. And we're going to go export actor. And this is what the actor function looks like. Okay. So we'll say root equals, and then we'll go spawn root, comma. There we go. The reason I did that is because that now gives me the IntelliSense here. Const. So if I look at spawn, it's going to have parent is of type any. Okay, so yeah, we'll make this explicitly any then to match the thing. Okay, great. Let's do this. Spectacle. Left half. What is using my CPU? It's a kernel task. I think this is the throttling of the CPU. Whatever. Okay, so then spectacle right half. Winning. Stateful actor. Okay, so this is the initial state. Is it? State is initialized to an empty object. Each time a message received, the current state is passed in as the first argument. Okay, so the nact controller or framework handles the state for me. Okay, so let's go interface. Menu controller actor state, and it's going to have active menu. I'm not sure what that's going to be, so I'll just make it any to start with. Okay, and then we'll do an interface here. Actually, it's not an interface, it's more an enum, menu controller active messages. So make it an enum. And then we're going to have activate menu. And then another one is on press. We'll call it button pressed. Okay. Equals 1. I'll do this. Make them string literals. Okay, so so we're going to say if message, what's the type of message? Any. Okay, so how do messages work? Let's have a look. Active communication. Messages. Let's go back. Yeah, we're going to send a message, so we dispatch what? Message.name. Okay, so we'll call it message.type. No, interface. Message, no. Activate menu. It's more like set active. We'll call it an activate menu. Activate menu message. And it has a type, which is menu controller activate messages, activate menu. And then it has the menu, which we'll make of type any to begin with. Okay, and then the other message that we have is a button pressed message. Okay, so interface, button pressed message. I'm using this to organize my own thinking about what I'm doing here, rather than like, oh, it needs to be, you know, strongly typed. Nah, not really. But this just helps me to think my way through the situation. So that's all. It's just when the button's pressed, that's all it is. So, and then we'll just do type message equals. It's either an activate menu message or a button pressed message to begin with. Yeah. So this message here, can I override the type? I think I can. Yeah. Okay, cool. So if it's a button pressed message, ding, then we want to dispatch state dot active menu So the other thing that we should do about state is we should say that it is a menu controller active state. And it has to have a default. Start it with nothing. And then the message is type button pressed. Let's do this to begin with. And that's all that it needs to do. Okay, now if the message type is activate menu, then we need to do, now how do I update the state? Stateful actors, do I return the state? Yeah, I return the state. Okay. This, in this sense, it's like Redux. Okay, active menu is going to be message.menu, like that. And then before I do that, I should dispatch nope, msg.menu and activate. Okay, so I should normalize the here we go. Boom! That's all it needs to do now. That's all the knowledge it needs to have. Nothing more than that. It's a higher level component than this menu here. But you can see that inside this class, it actually is tightly coupled to the various ones. So I can add new menus now without having to change anything in this controller because it's generic. It's a router. Okay, great. And then I should make a LCD controller actor. Let's just copy this over to the, get rid of the sound font library, LCD controller actor V. Okay. And what does the LCD controller do? Well, if we have a look in here, I got this thing here called LCD print. LCD controller actor. Okay. Should be able to import that. It's my LCD controller class. LCD print. Okay, so it takes some messages, right? Now, the kinds of messages it can take is well, let's rename this symbol to LCD controller actor messages. I wonder if anyone's watching the stream live right now. I think there's a window that I can look at that tells me. Need for Eat. Hey, Need for Eat. How you going? What's cooking? The actor model. What if I click on here? window. Is there like a chat window or something? Camera effects, comments and reactions. Here we go. Ah, yeah, cool. There we go. Add to the broadcast. Cool. LCD controller active messages. So I guess there's only really, which is print. Oh yeah. Yeah, it is kind of I'm working on my synthesizer. But it's not really going to be music stuff. It's going to be more just how to architect something with the actor model. It's the controlling the menus in the interface. So this here is my synthesizer. That's the keyboard that goes to control it. And the actual synth itself is in this box I put together. And it's got an LCD and a rotary encoder. So this is like an infinite scroll knob with a button that you can press to control the menus. Yes. Yeah, I'm actually writing an article about it for opensource.com, Raspberry Pi projects. I guess I also want to have this thing which is like a show, like a just for some period of time. What would I call it? Show modal? No, it's like a show toast. Show toast. And then hide toast. It's like a toaster. Exactly, I'm building a GUI interface. The GUI interface is with an LCD. So the control surface is the LCD and the rotary encoder. So it's turning up and down and button press. And then you have like sub-menus that you can go into. Exactly. Yeah, I'm using the actor model. Show toast. And hide toast. I guess we'll call this a print message. Type is print. And then message, which should be a string. And then line, which is a number. And it's optional. Show toast message. Takes a show toast message. Yeah. I used the actor model to build some other project a while ago. What was that for? Like a stats scraper. But this is, I think, a better match for the actor model, which is kind of like the Smalltalk idea of objects that pass messages to each other. So you can encapsulate control and encapsulate state. It's like pure object-oriented programming. This is a show toast. And when you show a toast, it's going to have a message, which will be a string. And then it's going to have a duration, which is going to be a number. And that's going to be, just so I can remind myself. Oh no. Easy way to do it. Duration milliseconds. There we go. And then hide toast. Do I need hide toast in that case? Yeah, I do actually, for when something finishes. Do I need then hide toast. I guess I should give it a name, like an ID string. So I should give this an ID as well. Don't know if I need that. Yeah, I should. I'll add it just in case, because some component might try to hide a toast that's not actually showing. Okay, so the messages that come in here are either a print message, a show toast message, or a hide toast message. Show toast message, hide toast message. Okay. So I should grab my LCD print function from here. Cool. Is it stateful? I don't think it is. I think it's stateless. So spawn stateless. Okay, so it doesn't take a state. Okay, so if it gets the print message, okay, does that typecast my, it does, very good. Let's change that to text. And so I'll just destructure everything off it. Text and line. I wonder if I can do this. I can. Cool. Okay, good. So LCD print text comma line, and that's all I need to do for that. Okay, let's say we get a show toast. Oh yeah, it does need to be stateful if I'm going to have toasts with IDs. Okay. So make it a stateful actor. In which case, it's going to have to take a state equals active toasts. Cool. Okay, if it's show toast, then let's dereference everything off the message to start with. Okay. I wish you could do like everything. Text, type, message. Don't need the type. So what we do then is LCD print the text onto line 1, and then okay, so extend the state. Active toasts. State.active toasts. It should only be one toast active at a time. Okay, this is going to be interesting because basically what I'm going to do is this, set timeout. And then in the timeout, I'm going to do LCD print line 1, put nothing on it, on line 1, and then set that to the duration milliseconds. But if they've done hide toast, so hang on, if duration milliseconds is not equal to 0, then we need to set this timeout. How do you deal with asynchronous activities in the state? If yeah, okay, it's not pure Redux. So I think what I need to do then is it'll be inside a closure, so I can do state equals what? Ah, that's why. And then, yeah, okay, so then ID true. Oh, I'm not able to mutate the state asynchronously. What happens about stateful actors? What about asynchronous mutation of the state? No, okay, I see what I have to do. I have to create another actor. LCD toast actor. I have to delegate this to this actor. Is it a stateful actor or a stateless actor? It's a stateless actor. Got caught in a airport somewhere. So, dispatch and spawn, stateless. Get rid of menu for the time being. Toast actor. It's going to be spawn stateless. Okay. So, export const actor. I should give them better names. Like LCD toast actor. Okay, it's stateless, so it takes a message and a context. Actually, take a root. And then if I say spawn, no. So if I say spawn stateless, and that takes a message and a context. Yes. Ta-da! Why doesn't it like that? Oh, okay, yeah. Can I tell it to make it explicitly? Yeah, any. Good. Why can't it? Parent function. Okay. Like that. Okay. So, so what I do in the controller actor here, first thing we'll do is rename this to an LCD controller actor. And what we'll do is we'll spawn, no. Yeah, so I need to import the LCD toast actor. So make sure I've saved this. Go here. LCD controller actor. Okay, so spawn stateless. Yeah, this thing is stateless. The LCD toast actor, import it. And so just go const, I don't know, LCD toaster. Yeah. And then I need to pass in this thing. So get rid of that, go down here, put it in here. What doesn't it like about this? Property assignment expected. Yeah, no problem. Get rid of one of these, I think. Yeah, okay, it's balanced. We brought balance to the force. So what I need to do is here I need to spawn stateless. Actor equals this. And then I need to spawn actor. LCD toaster. No, that's right. Pass in the actor. Yeah, okay. And then return, yeah, the LCD controller actor. Now, did I do that right? Let's have a look. System. Okay, hierarchy. Child actor, yeah, okay. Do I know what I'm doing? No. ctx.self. Okay, spawn stateless actually takes, I think it can take a name. Getting started. Spawn stateful actor stateless. Yeah, the name is the third parameter. So here, the name should be LCD controller. Okay, and then the name of this one is going to be LCD toaster. Okay. I should make all the actors into like strongly typed strings. Okay, so dispatch does what? Is the name. Okay, so we spawned that actor. We got a local toast actor. Okay, so if there's a duration, then what we're going to do is we're going to dispatch a message to the toaster. Yeah, I got dispatch, good. So dispatch takes 2 arguments. It takes an actor and a message. Hierarchy. I have to get it from the context. Has children. CTX children get. So I can go ctx.children.get. Takes a string. LCD toaster. Might be null. Okay, so const toaster equals ctx children get LCD toaster. The other way I could do it, actually, that would be real easy, would be if I said, could I do this? Toaster equals that. It's an actor ref. And then I just dispatch it to the toaster. Oh yeah. Boom. Let's put it in here. Type actors. Should work. No, can't be a... No, it has to be an enum. And I don't think I can put it in here. No, I can't. X, save. Oh, this sucks. Ugh. Yuck. Oh, no. Okay, now it's starting to get disgusting. Actor constants. Nope. Could do it like this. Yeah, okay, I'll do it this way. These will just be numbers. So, toast actor. Actor dot LCD toaster. LCD controller actor. Actor dot actor dot LCD controller. What don't you like about that? If it doesn't like it there, why did it like it in the other one? LCD toast actor. Spawn stateless. Parent any. Doesn't have a name. Stateless actors don't have names. getting started. Can you explain Lacom 5 on when someone should consider using the actor model? Immediately on anything in order to understand it. And then you'll figure out when it's a good impedance match for a problem. It's the small talk idea of object-oriented programming is it's basically real object-oriented programming. This idea of object-oriented programming that we have with like classes and stuff is not really object-oriented programming. There's like too much leaking of state and coupling between, you know, methods. Even the law of Delphi, which is that you shouldn't have more than one dot. You know, like this dot something dot something dot something. You know, you're reaching through a property of the class into that object and then executing one of its methods deep inside it. That leads to tight coupling. And that's entirely possible when you're using, you know, the normal class-based programming. So you start leaking knowledge of internal implementations between classes. When you use this actor model, you can't do that. Everything has to be done through message passing, so it enforces actual object-oriented programming. So I would just use it. The last project I used it on was like way overkill, but it gave me an understanding of how to use it so that now when I found this problem, which is you have these menus and submenus, and you know the menu controller now has knowledge of what's inside each of those menus and how they interrelate with each other, but you don't want that kind of knowledge to be concentrated in one place or spread throughout the different menus. So I found myself, in order to add a new menu, I was having to edit multiple places, whereas with this I can just add another object that takes messages and then the menu controller will just delegate control to that menu object. So you can now extend the system by adding more and more menus and they just take control of the user interface. And then the menu controller's job is simply to delegate control to a submenu. That's all it does. And then the submenu can call to the menu controller and say, now delegate control to this other submenu. So, you know, when you click on like exit or go into a deeper menu, that submenu object now tells the menu controller, delegate control to this other menu, and it's done. It doesn't know anything. Otherwise, I was like passing on press events down through the hierarchy of submenus. You know, the top control menu knows this menu is active, and then that menu has now activated a submenu, and that submenu has activated another submenu, and then they were just having to pass this thing down, and each of them had to know about the state, and yeah. ZB uses the actor model internally, which is how I kind of got into it in the first place. Stateless actors don't have names. Okay. So that's interesting. In that case, I think I should make it a stateful actor and have the state